This is an example from the second section of problems from Wednesday. And I think it's helpful to start sketching out what you have here. And this should be an adventure for me drawing this here. So let's see how we do. So it says the graph of a sinusoid function. So this means it can be cosine or sine as the parent. Has a maximum point at 0, 7, and then intersects its midline at 3, 3. So let's draw this out as best we can here. All right, not terrible. We're going to use this line right here. Not bad. All right, so it has a maximum point at 0, 7. So 0, 7, let's call it right there, 0, 7. And then it intersects its midline at 3, 3. So I'm going to go over by ones. 1, 2, 3, and then 3, 3, about right there. So my units are about 3 going up and down and about 1 going across. So 3, 3 is its midline. So maximum to the midline could look like that. And then the graph's going to keep going. So this is 3, 3 is the middle line of our graph. And then it's going to go down the same amount. So it was 4 above 3, 3, so it's going to go 4 below. And it's going to do that in the same amount of space. So after 6 units, it's going to be down at its minimum. So 1, 2, 3, 3 more. And its minimum is going to be 4 units down below here. So that's going to be the 0.6, -1. And we've got half a period here. And now this graph's going to do the same thing every quarter period. And it'll get back up to the top here a little ways down the road. And the question when we get one of these problems is really what are the 4 properties of this graph? So what's the amplitude? What's the period? What's the midline or vertical shift? And then there's no horizontal shift. This looks like a cosine function because at x equals 0, it's right up at the top. It could also be a cosine function if at x equals 0, it was at the minimum value. And that would be a negative number multiplied out in front of your cosine. So it's pretty easy to see as we look at this. Our amplitude is from y equals 3 up to y equals 7. So that's 7 minus 3, an amplitude of 4. The period, so this was 1, 2, 3 units for a quarter period. 4 of those is going to be a total distance. This will be at its maximum again at 12. And then the midline, or the vertical shift here, they gave that to us in the problem as the y value, y equals 3. So the vertical shift is plus 3. Now our equation, our basic equation is y equals, and the letters we used were b times, we're going to use cosine for the parent function. You could certainly use sine, ax plus k. Now this k is your vertical shift. That's the easy one, plus 3. This b is your amplitude, also the easy one. These vertical properties are really easy to put into the equation. It's this guy in here that usually is the trouble. This period is always 2 pi over a, the number that's the coefficient of x. So we could just do a quick little switch here if we solve this. 12 equals 2 pi divided by what? Well, that would mean that the a is 2 pi over 12. And you should certainly, see. Let's reduce that, rewind. There we go. 2 pi over 12. You could reduce that down to pi over 6. Now putting this in correctly, remembering to put the x in there, also a problem for cosine function. Use it. Use the fraction. Ooh. Use the right arrow now. Can we use the fraction? Nope. We're going to do pi, type pi, divided by, now we do the, no. Let's do a parentheses. I see what your frustrations are here. Use the pi over 6, x, and then last thing, plus 3. And now we cross our fingers and hopefully we get confetti.